Hello, I modeled the rocket team's payload that will be in our custom-made rocket flying to an altitude of 10,000 feet. The payload is testing the consistency of different baffles in fluid tanks. The main thing I need to know before manufacturing the payload is whether the payload mount would be able to handle the rocket's landing, which usually isn't that high of a force. I simulate 3 different cases with the loads applied to each of the discs. The first being 3-pound forces, the second being 15-pound forces, and the third being 30-pound forces. Usually 15 pounds would be the most non-destructive landing would be. As you can see in the pictures, the payload holds up pretty well, which is what I expected, as it's similar to payloads I've built before, and even in our catastrophic one, it survived pretty well, since we have a carbon fiber rocket. I learned that super detailed parts aren't always needed, or can also slow down like simulation and meshing for the FEA simulations. So I suppressed the threads on the threaded rod. For the fluid simulation, I unfortunately don't have the animations, as my PC's power supply broke down and I don't have access to the files anymore. But I did learn that to model the preset volume of water flowing out of a container, you have to model the water itself as like a separate body within one part, and you have to label it as a like non-solid when you're doing the SFD study, and you have to track the immersible liquids in the part. I also use the gravity function in the wizard option to model the rocket's acceleration over time, which I got from as a separate which I got from a different simulation software called OpenRocket, which gives me the values of the acceleration during the duration of the flight. And this helped me get a more accurate analysis of the fluid. I also learned how useful equations are for part modeling. Being able to change the outer diameter of the tanks and everything automatically adjusting is a huge time saver.